Right, okay, so this first one I'm a little bit more confident in, because this is part of the advanced higher course. So you're right in that it's implicit differentiation. We need to obtain dy by dx and hence find the tangent to the curve. Excuse my dodgy writing on this tablet. So when we differentiate y squared, remember that we're differentiating it with respect to x. So we differentiate it as if we're differentiating it in respect to y, so we would get 2y. But because we're supposed to be differentiating with respect to x, we have to write dy by dx beside it. We're kind of multiplying it by dy by dx, and that counteracts the fact that we've differentiated it in terms of y. The x squared is fine, because that'll just differentiate normally. That gives us 2x. Equally, the 2x will differentiate normally. That will just give us 2. And then the 4y, we've got a similar problem. It's a y term. We've got to differentiate it with respect to x. So we differentiate it normally, which would be minus 4. Minus 4y would obviously become minus 4, but then you have to multiply that by dy by dx to give you what it would be differentiated with respect to x. And then 15 differentiated is 0, which is often the mistake that we make with that 15 stage, because we forget that when we differentiate 15, we get 0. In order to obtain dy by dx, we now need to rearrange all of this. You can do this in different ways, but what I would choose to do is look at my plus 2x and my plus 2 there, and first of all, and take them across to the other side of the equation. So I'm going to have 2 dy by dx minus 2y, dy by dx, minus 4 dy by dx equals minus 2x minus 2. And then from there, what we'll need to do is we want dy by dx on its own. So we're going to take dy by dx out as a common factor, which will leave me with 2y minus 4. And that's equal to minus 2x minus 2. And then that's dy by dx times the bracket, so we can just divide by the bracket. So we'll have that dy by dx is minus 2x minus 2 over 2y minus 4. And obviously you can simplify that, because you can divide everything through by 2 to get minus x minus 1 over y minus 2, just by dividing every term through by 2. So we've obtained dy by dx. We've now to find the equation of the tangent at 1 minus 2. So when we get the equation of the tangent, we're going to need two things. We're going to need the gradient of the tangent. Gradient of the tangent is given by this dy by dx formula, and we've been asked to work this out when x is 1 and y is minus 2. So the gradient is going to be minus 1, because that's your x. Okay, minus 1 over y is minus 2, minus 2. So I've got minus 2 over minus 4, which will obviously be positive 1/2. And then from there, equation of a tangent, well, equation of a straight line, y minus b equals m bracket x minus a. M is 1/2, and your a and b are your 1 and minus 2. So I'm going to have y plus 2 equals 1/2 bracket x minus 1. And then multiply that out, tidy it up however you would normally tidy it up, whether you leave it equal to 0. I tend to leave things as y equals. So when I multiply that out and tidy it up, I'm going to have y equals 1/2 of x. It'll be minus 1/2 minus 2, so minus 2.5 or minus 5 over 2. Or you might have something equivalent like 2y equals x minus 5 or whatever. So that is the first one. Hopefully that makes sense, but if not, give me a shout and I can go through it again. Second one, yep, as you said, it's definitely quotient rule. There's one little bit here that I need to look up, because I can't quite remember the derivative of cos x, because it's not something that I've done since I was at uni myself, I don't think. But you're right, it's quotient rule. So we've got our, I don't know what notation you're used to using, so I use U for the top line and V for the bottom line. You might use F and G, different people use different things. But the process is going to be the same no matter what. So U is going to be cos of 2x squared. Okay. And V is going to be e to the 3x plus 5. So V dash I can do nice and easily. V dash is going to be 3e to the 3x. Just thinking about your chain rule there, you've got to multiply by 3. The 5 obviously disappears. And then the derivative of cos is going to be, I've just looked it up, give me 2 seconds. Okay, yeah, so derivative of cos x, okay, is just, I can't ever remember, I think we call it sine. Okay, so the hyperbolic sine of x, okay. But obviously we've got to use chain rule here as well because that's a 2x squared, so we're going to have to multiply that by 4x. So u dash, this is why I shouldn't use u and v because my writing looks really dodgy. Okay, so u dash is going to be 4x times the hyperbolic sine of 2x squared. Okay, and then from there, we're just going to have to use our quotient rule. So we've got that dr by dx is going to be u dash v minus uv dash over v squared. Okay, so u dash was 4x times the hyperbolic sine of 2x squared. And we're multiplying that by v, which is e to the 3x plus 5. And then we're subtracting, so this is all still in your numerator line, we're subtracting u times v dash, which is going to be the hyperbolic cosine of 2x squared times 3e to the 3x. And that whole thing is going to be divided by v squared. So, which is obviously e to the 3x plus 5. All squared. You probably want to rewrite that a little bit neater. I tend to run with e to the 3x plus 5. With, I would actually probably put the 4x on the outside of that. So I've got my 4x e to the 3x plus 5 times the hyperbolic sine of 2x squared minus 3e to the 3x times the hyperbolic cosine of 2x squared all over e to the 3x plus 5 all squared, and there's not particularly a way I would simplify that at this stage. Hopefully that helps. If it doesn't, please get back in touch if there's things that you don't quite get, or if it doesn't match maybe answers that you've got, and I can work on it.